Let's begin with the Emerging Technologies for Engineers, Chapter 7 on Data Science. So, data science combines statistical analysis, computational techniques, and domain knowledge. It involves processes like data collection, cleaning, and analysis. And here, our goal is to extract valuable insights from the data. Data science helps information decision making. It drives strategic actions based on data insights. So, the purpose of whole data science is to extract some useful information from the data that we have to make some vital business decisions, to make strategies. And here we need to analyze this data using different types of computational techniques. But before using this data for analysis, we need to clean it and make it fit for analysis. How this is done, we will see later in this video. So the expansion of internet and communication. Today, actually, data is the fuel of all AI applications, of all data analytics. And today, all these fields are possible just because we have a lot of data. How are we generating this much data? Because we have the internet, the communication technology, even your smartphone. Every second, it is recording your location. You exchange so many WhatsApp messages every day. So all this data about you that is constantly being collected. Then we are using social media, we are writing reviews, we like and dislike, so all that is we share images, so that is all data about us. Then real-time data processing involves decision making for organization. So data science focuses on acquiring this data, collecting it, integrating it, and processing large volumes of data. The goal is to transform this data into some actionable knowledge for informed decisions. So the core aspects of data science include data collection. You have to collect all the data from different sources and store it, manage it in a database. Then utilize that data for analysis. We build certain machine learning models to make prediction for classification, aggregation. We also analyze this data and view the insights using different types of graphs. And that is the part of data visualization. In data visualization, we make different types of graphs. All these things will be covered later in this video. So, but first let us analyze what is data. See, in today's world, data is omnipresent. Data is everywhere. In whether it's markets, marketers are using data, analysts are using, researchers are all using data to understand business in a better way. Accurate handling and storing of data is critical for obtaining accurate results, with data characterized into qualitative as well as quantitative. While qualitative data includes nominal and ordinal, quantitative data includes discrete and continuous. So, as the name suggests, discrete means only particular numbers. For example, uh, your marks, right, is a number, numerical value. It's discrete. But continuous, for example, the temperature, the rainfall in the last 7 days, it's uh, data that you're getting continuously is continuous data. Discrete means it is discrete in interval. It's just one number and that's it. Qualitative data, qualitative can be nominal or ordinal. Nominal means named category for what is the color of your hair is a nominal value. But ordinal means category is with some implied order. For example, what was your rank? What was your rating? So there you are using some ranking system, rating system. So that is an example of ordinal value. For example, the grades a student gets is an example of a ordinal value. Qualitative data is categorized into groups using labels. So, for example, if we have grades for the students, so we are grouping them in labels: A grade student, B grade student, C grade, D grade, outstanding student. So, it is commonly used to classify observations in statistics derived from qualitative data or grouped quantitative data. It helps in organizing and summarizing the data. For example, instead of talking about every individual students, we always give summarized features that we have 4 outstanding students in the class. We have 10 average students. We have, uh, say, 7 A grade students. So we always try to summarize this data to make better interpretation from that data. So then let's see the difference between nominal and ordinal. So nominal mean example, eye color, gender, religion. So that's a nominal value, and ordinal data economic status. Some have very high, low, middle economic status, medium, then educational level similarly. So here there is no intrinsic order, but here there's an order, purely qualitative or categorical. Here it's in between quantitative and qualitative. It cannot You cannot perform mathematical operations here. On the eye color, gender, religion, there's no mathematical operation that can be defined, but here, yes. Then let's find out the analysis of categorical data. Now, to analyze categorical data, we often use some frequency tables, cross tabulation, chi-square test, contingency table, bar charts, or odd ratios. Frequency table displays counts or the numbers of different categories. How many uh, high income group, how many people in the high income group, how many in the middle income group, like that. Cross tabulation examines relationship between two category variables. For example, if I want to understand how many students from EWS scored above 90, uh, because since there are two category values, so we will not take marks. We will say how many students from EWS are are uh, are also in the A group, are also outstanding. So here we are making relationship between two category values. Chi-square test determines significant association between. So how are they related? For example, uh, does belonging to a high income group makes you hardworking? If you want to see how closely they are associated with each other, is there any relationship? So that is done using chi-square test. Contingency table shows the frequency of all unique pair of values in two categorical values. Then bar charts is used to visualize the distribution of different categories. We'll see this later in this video. Then odd ratios measure the association between two categorical values. So here, this and this cascade test and odd ratios both helps us to identify the association between two categorical values. Quantitative data can be is represented using numbers. So it is used to access customers. For example, you're taking a rating, how customer rate you 5, 4, 3, 2, 1. To understand the business performance, it allows for statistical and arithmetic processing is possible on numerical data. It provides valuable insight for business research and decision making, easily analyzable compared to descriptive data types. So numbers can be analyzed more easily than descriptive data. Difference between discrete and continuous data. Discrete data is countable and finite. Continuous data is not measurable. It's usually in fractions or decimals. Represented by bar graphs, it is represented by histograms. Values cannot be subdivided because but here values can be different. For example, if the uh, your body temperature, your temperature of the city in the last 30 days can be subdivided. For example, if it's in between, say below 30, the weather is pleasant. If it's between 30 to 40, it's hot. And if it's above 40, you can say it is very hot. Then it has clear spaces between the values. It forms a continuous range. For example, temperature, weight, height, length. And here we have number of students, days in a week. So it's a discrete value. Now, integrating data science into organization often faces challenges due to different goals. And there are always conflicts between the data scientists, analysts, and business teams. The healthy data science organization framework addresses these gaps. They want to bring everybody on the same page. So it includes tools and resources to enhance data-driven decision making only. Focus here is to understand the business better way and acquire the data, perform modeling and deployment to get valuable insights. So key principles are understand the business and decision making process, establish some performance metrics. For example, if we say, for even if a student is, we say if you get above 70, only then I'll say that your performance is good. So we need, even in business, we need to have some performance metrics. When will you say that the business is doing well? Architect end-to-end the solution. So based upon the metrics, you can then define better solutions. For example, if you see that sales often declines in a certain month, then you can give an additional discount. So that is a data-driven decision to boost the sales. Build your toolbox of data science tricks. Unify your organization's data science vision and keep humans in the loop. Keep everybody in the team in loop. Inform them, take their advice. Only then it will be a healthy data science project. Now, importance of data science process. Industries recognize the benefits of data science and machine learning. Businesses of all sizes, big or small, leverage data for insights and growth. Applications span manufacturing. This data science is used in manufacturing, healthcare, automobiles. The goal is to convert data into actionable insights and use for strategic decision making to finally enhance the revenue. Now, hyperparameters are external setting for a machine learning model training. They differ from parameters which are learned during the training. Examples include neural network, how many layers will be there in the neural network, how many branches will be there in the decision tree. They influence model architecture, learning rate, and complexity. Hyperparameters are mainly set before the training. So I hope to understand the difference between hyperparameters and parameter is clear. Parameters are learned during the training, but hyperparameters are set before training. So, hyperparameters influence affects the model architecture, learning rate, and complexity. But parameters are just used to perform the task they are supposed to do. Now, metadata stores means metadata is data about data. So, it's generic metadata like the last process feeds entries date. When was the data entered last? It prevents duplicates by aiding component data science process, for example, data, if we have a lot of data, we first collect the data from different sources, prepare data, prepare means cleaning and transforming it. Cleaning means, what is cleaning exactly? We'll see just in the next slide. Then we explore the data, identify labels and features to be familiar with the data basically. Once we are familiar with the data, we know that what the data is, what information it conveys, then we make a machine learning model for future analysis, for identifying the trends, for predicting some sales or prices, for whatever, and then visualizing the results. We'll see this how. But the first task in any process is problem defining and setting objectives. So identifying specific problems such as improve why are you creating this data science process? Whether you want to retain the customers or you want to predict the sales. Understanding broader business context, including what industry dynamics and company goals. So whatever process you are doing must align with the goals of the company. Engaging with the stakeholders to gather insights into their needs and expectations. So we just don't go and randomly start a project. We need to talk to our stakeholders. We need to understand their needs and expectations. And then we refine the problem statement to make it more specific, measurable, and with set objectives. Assessing the availability of relevant data sources, we identify from where we have to take the data. We identify what will be the key performance indicators, and we then set the scope and constraints of the project regarding budget, timeline, and resources, depending, of course, upon the complexity of the project. Documenting the problem statement, objectives, and stakeholder requirements. Then, once we have identified the sources, now we actually start collecting the data both from the internal as well as external data sources. That data can be structured or unstructured. Then we evaluate the quality and suitability for the data that we get. If the data is not of high quality, we need to clean it, we need to transform it. Then we do EDA. EDA means like exploratory data analysis, in which we need to understand the data set structure, size, variable, what information it is conveying. And we need to ensure that data integrity and determine if additional data is needed. So, what are we doing in data process, pre-processing, and cleaning? We see if there are missing values, we handle them. We either fill them with average values or with zero or whatever the rule of the company says. How you have to handle it is specific to that company's guideline. Then we need to identify outliers. Outliers are extreme values, right? We need to remove those extreme values. For example, if all your customers belong to the age group of 18 to 35, but if you have one customer of say age 80, so that's an outlier. It's an extreme value, too far from the normalized set of values. So we remove those outliers. Addressing data inconsistency, if the data is inconsistent. For example, if you're taking data from two different sources, in one place the gender is written as male and female, and in other places it is written M or F. So we remove the inconsistencies, we bring them in a standardized format. Then we perform feature engineering to create new variables. For example, you have two fields, cost price and the selling price. So we do feature engineering to create a new variable which gives more information, whether it was a profit or whether it was a loss, right? Then ensuring data quality and preparing it for analysis. So we also identify if there are any other quality issue and we do whatever is required to enhance the quality. During exploratory data analysis, we generate descriptive statistics. We call it percentiles are created. The data is standardized, normalized, uh, and then we see the correlation between different variables. We do visual representation. We see histograms, scatter plots, box plots to identify, to visualize that data, to identify missing values and outliers even at this stage, performing correlation analysis, exploring data distribution, and using dimensionality reduction techniques. For example, if there in a data set you have 50 or hundreds of dimensions, but for the purpose, the current purpose at hand, you may need only 10 attributes. So to identify the redundant or the irrelevant features for this particular task, we do exploratory data analysis. We do dimensionality reduction techniques. Then generating hypothesis for further investigation. We do hypothesis testing. Then finally, we build a machine learning model. We need for that we need to select an appropriate algorithm based on the problem type and nature of that data. Training model is created, and we evaluate the performance of the machine learning model using the testing data set, iterating and refining until the accuracy is high enough to be used. Then interpret whatever the results that we get, the predictions, what we get from machine learning phase is again plotted. The results are communicated clearly so that the stakeholders can take the desired action, the correct action. Deployment and monitoring involves installing the model at the user's machine. So for that, integrating models into business workflows for decision making, monitoring the performance of the model, and if required, you need to update it and retrain it if the performance is going low, ensuring data quality and addressing issues like data drift, gathering feedback, constant feedback from constantly getting feedback from the users, and maintaining proper documentation. Then benefits of data science process, it improves decision making in an organization, increases efficiency of business operations, enhance customer experience, competitive gives you a competitive advantage, helps you to predict value of sales and predict whether a particular customer will be your potential customer will turn to be a real customer or not. So make all those kind of predictions, personalized marketing and customer segmentation. For example, we can do targeted marketing. For example, those people who often buy during special discounts. So you can, in the period where there is not much sale, you can offer those customers more discounts. Then we can have better healthcare outcomes, efficient resource allocation, continuous improvement, innovation, and new opportunities just because of data sciences. For example, now we see if your data is analyzed, for example, if for example every 6 months if you go for a blood test report, then the reports always compares your previous report with your current report. So that gives you insight whether your the performance of your health is going up or going down, where it is lagging and where it is improving. Now, challenges in the faces of in the data science processes, data may not be of good quality. So you need to spend 80% of the time is spent for cleaning the data. Then data has to be taken from multiple sources. Collecting data from multiple sources, standardizing them, normalizing them is not an easy task. Identification of what is the real business issue. Why do we collect the data? It is very difficult to understand the real cause. Then communication of results to non-technical stakeholders is another challenge. Not everybody will be from IT background, and decision makers are basically not from the IT background. So to make them understand of the results is difficult. To maintain data security, efficient collaboration between different teams, selection of non-specific performance metrics is also another challenge in the data science process. Then there are different tools and platforms for data science to take actionable insights. They support both data scientists and decision makers. Functions include data analysis, correction. So there are different tools which help you to analyze the data, collect the data, make the machine learning model, create interactive dashboards, and uh, there are tools integral to all the phases of data science project. For example, here are some tools for databases. We usually use PostgreSQL. For web scraping, we usually use Beautiful Soup. Then data analytics, we usually use Python and R language, Tableau and Julia also. So there are different tools for different purposes. Now, data analysis transforms raw data into meaningful insights. We've learned this. It includes statistical, mathematical, and computational techniques. Key steps include inspecting, cleaning, transforming. This is just a summary of what we have understood so far. So, and it generates insight that helps us to identify patterns, trends, and correlations between variables. Organizations use data analysis for better decisions and improve efficiency. There are different types of analysis that are usually performed, like descriptive analysis, diagnostic analytics, predictive analysis, and prescriptive analysis. For example, descriptive analysis looks for historical data to describe something, to understand its past performance and identify causes of what happened in the past, causes of success or causes of failure. It is commonly used in marketing, management reporting for sales, marketing, what went well and what didn't do well. DMART, for example, can analyze past data, sales data to determine which products had high demand and ensure adequate stock for the future. Diagnostic analysis explains why past events occurred. So this is what had happened and this is why had it happened. Complementing descriptive analysis. So diagnose, you're finding the root cause. It identifies patterns and reasons behind certain outcomes. It can use diagnostic analysis to understand why. To which, here it was which products did well and here why. So what went wrong? What did wrong? What, which, here, why. Now predictive. Predictive analytics use insights from descriptive and diagnostic analysis to forecast what will happen. It predicts what is likely to happen based on past trends. For example, Amazon and Netflix use predictive analytics for recommendation systems, suggesting what products you should buy, what books you should read, right? Prescriptive analysis builds on predictive analysis by suggesting the best actions to achieve. So, doctor prescribes the medicine. So, prescriptive analysis tells you what decisions you should take for optimal outcomes. For example, Google's self-driving car uses prescriptive analysis to make real-time decisions on when to turn, when to slow down, when or similar to a human driver. Data structures. Data science is a diverse and rich field of study. Understanding data structure is fundamental in this domain. It applies to both academic study and practical applications. Data structures enable insights into how online world operates. Mastery of data structures supports effective data science practices. There are different types of data structure basically means how are we going to store that data? How are we going to structure the data? So building a solid foundation structure is key to the business success. We have two types of data structures, linear data structure and non-linear. So linear means, even in linear, we have two bifurcations, static and dynamic. So as an example of static data structure, we have the arrays. For dynamic data structure, we have queues, stacks, and linked lists. Similarly, for non-linear data structure, we have trees and graphs. We look into all of them. So here it's an array. So as we said, array is a static data structure which is linear. Linear means one after the other. So in a line it occurs. So array, if you see here, this is at address U is stored at address 200, B is stored at address 201, F is stored at address 202, D. So consecutively the values are stored. So if you and they are usually indexed. Index means number. For example, our index starts from 0. So at index 3 we have D. At index 6 we have C. At index 0 we have U. So this is an array. You can store, say, the roll numbers, the marks of all the students in an array. Now, another data structure is a queue. What is a queue? Queue is a dynamic data structure. Why is it dynamic and why is array static? When you are creating an array, you have to tell how many blocks to reserve. So here, 7, 8, 9. Total 10 blocks are reserved. How 10? And total 10 blocks are reserved and the numbering starts from 0 to and goes till 9. It is static because you have to specify how many blocks you want to reserve in the memory. But dynamic means The size can increase or decrease anytime. For example, this is a queue. What happens in a queue? The element when we stand in a queue, suppose you are standing in a bank in a queue. So the person standing in the front of the queue will be serviced first. A new person that comes in the bank will stand at the end of the queue. So DQ means deleting who will be processed first, who is there, the element that is there at the front of the queue. So 2 came out from here. Next 3 will come out. Next 4 will come out. Then 5, then 6, then 7, and then 8. If a new person comes, for example, if this new element 9 is coming, it will be appended at the end. So it will come after the 8. This position is called the back, tail, or rear end of the queue, right? DQ means removing an element from the queue, and NQ means adding an element to the queue. In a queue, the new element is always added at the end, and the element from the first position is deleted. Now we have stack. Stack may we put the elements one after the other in such a way that you can insert and delete only from one end. For example, if we have stack, you have seen the stack of dishes. You place the next dish over the last dish. So if you have a stack of books, you will take out the book that is at the top. So here you have three values A, B, you have two values A and B. If you have to place C also, it will be placed above B. If you have to place another value D, it will be placed above C. So only this is the topmost position. You can add or remove elements only from the top. For example, if you want to delete an element, the topmost element that is C is taken out. After that, B will go out and then A will go out. So this is called a stack data structure. Now we have linked list. Linked list may it's like a train. You have different compartments all connected to each other. So this is the head of the linked list, and this is the last node. The last node always points at is connected with null, right? It stores null. So A is pointing to, like we create when small students, they create our teacher asks them to create a line and they have to hold one hand, hold hand of the student with the hand of the previous student. So they are chained basically. So A will point to B, B points to C, C points to D, and the last node points to the null. Then we have a tree structure. This is a non-linear data structure. Why is it non-linear? Because they are not coming in one line. So far, we had all the data structures coming in one line. So that is why they were called linear data structure. But tree is not coming in one line. Here we have the root node. Then we have root is the parent of all the nodes in the tree. So this is the parent node. Now 2 is the parent of 6 and 7. 7 is the parent of 14. So 6 is called the child node. 2 is called the parent node. 1 is the parent of nodes 2, 3, 4, 5. 2, 3, 4, 5 are child nodes of node 1. So we have trees in different levels. So this is level 0. Root is at level 0. Next is level 1, level 2, level 3. So there are total 4 levels here in this tree, starting from 0, 1, 2, and 3. The nodes at uh, these are called the terminal nodes are called leaf nodes. Those nodes which do not have any children are called leaf nodes. For example, 11 does not have any children, so it's a leaf node. 17, 18, 19 are leaf nodes. 15, 16 are leaf nodes. 8, 9 are leaf nodes because they do not have any children. 14 is a leaf node. 6 is a leaf node. Right? Sibling means two nodes having the same parent and at the same level. So actually 8, 9, 10 are siblings. 15 and 16 are siblings because they have the same parent and they are at the same level. 17, 18, 19 are sibling. They have the same parent 13. 11, 12, 13 are sibling because they have the same parent 5. One root node 1 has 4 children and these 4 child nodes are siblings. 2, 3, 4, 5 are siblings. Now data structure graph. In graph you have nodes and edges. These nodes are connected with edges. For example, there's a path from 0 to 1. There's a path from 1 to 2. If you have to go from 0 node to 2 node, you can traverse from 1 and from 1 you can go to 2. You can also do one thing. You can from 0 you can go to 4, 4 say you can go to 3, and then you can go to 2. So there can be multiple paths to go to the same destination. For example, you can also take this path from 0 to go to 1, 1 say 4, 4 say 3, and then 3 say 2. You can even go from 0 to 1, 1 to 3, and 3 to 2. So this shows a graph. Data visualization transforms complex data types into visual formats that are easier for human brain to understand. We often understand things better when they are graphically presented. So we have different for visualization. We have different type of charts, graphs, maps, and dashboards. To represent numerical data, we have already understood that numerical data visualization includes continuous data and discrete data. Similarly, categorical data can have binary data, nominal data, or ordinary data. Then we have different types of visualization techniques catering to different type of needs. For example, bar charts, line charts, pie charts, scatter plots, histogram, heat maps, box plots, and area charts. Bar charts are basically ideal for comparing categorical data. We've already read this. Displaying frequency. Bar charts offer a clear visual representation of values, discrete values. Histograms are used for continuous values. Then line charts are used for visualizing the trends over time. Pie charts displays parts of whole. For example, if I say 25% students took Hindi language, 30% prefer to take English. So part of a whole can be represented using pie charts. And we have scatter plots to understand the relationship between two variables. Heat maps, again, to understand the relationship, how closely two variables are associated with each other. Box plots are basically used to identify the outliers and the median value. Area charts are similar to line charts, but with area line filled with these charts. I'll show you all the types of charts. Uh, okay, from Google, I'll show that. Bubble chart, they enhance scatter plots. They're like scatter plots, but they include a third dimension. The size of the bubble varies to include the additional dimension. Tree maps, they are used to show depict hierarchical data. Violin plots, they combine aspects of box plots and kernel density, providing a detailed representation of data distribution. Word clouds you must have seen. In word clouds, the most frequently used word is shown prominently. 3D surface plots helps us to visualize 3D dimensional data, illustrating how response variable changes in relation to two predictor values. Then we have network graphs and Sankey diagrams, which shows time series analysis basically. We have different tools for visualizing. Tableau, we usually use Tableau, and Power BI. Then data mining. Data mining involves analyzing large amount of raw data to identify patterns. It extracts useful insights for decision making. Business use it to understand customer behavior and preferences. Outcomes include improved marketing strategies, increased sales, and reduced costs. Data mining relies on data collection, warehousing, and computational processing. You must be thinking data mining is similar to data science, but no. There is some intersection, but they're not exactly same. Data science use scientific methods, processes, algorithms, and systems to help extract insights from the data. So it's data science is extracting insights from the data, but data mining discovers patterns in large data sets through the use of various other methods. So if the data set is very large, we are not data science is basically for small or medium sized data set, but for large sets we use data mining. So data mining is core discipline in data science. But before winding up, let's see different types of charts, how they look like. I think this would be a better figure. So this is a pie chart, this is a bar chart, this is a columnar chart, this is a line chart, this is the area chart where we have lines, but the area is prominent, how much area is covered. Then we've read about bubble chart. the size, there are three dimensions, X dimension, Y dimension, and the size of the bubble varies to plot the third dimension. So here's a scatter plot similar to a bubble chart. And let me show you a word cloud. So the word that is most prominent, frequently used is boulder. Can be then we have after health, we have exercising, sport, people. So the smaller the word, less frequently it is used. More frequent words are bold and more prominent. I'll also show you a heat map, which shows you how strongly two variables are associated. For example, see this is a heat map. Uh, you can easily get an idea. See, this value is -1 and this value is +1. So the lighter value, this yellow values are more, means 100%. Actually, these values are same only. So if you have shades of green, that is, they are, and see the val number is also written. I'll just show you where the numbers are also written. I would like to show that. Yeah, yeah. When two, see the correlation is actually varies from -1 to +1. So if the value is 0.26, if it, we usually say if it's greater than, we keep a threshold value. If this correlation value is greater than 0.5, we say they are strongly related, right? If it's from 0 to 0.5, it is less strong. The two values are less strongly correlated, right? So if its value is -0.75, this means they are strongly correlated but negatively correlated. If one value is increasing, the other value is decreasing. If it's plus 0.75, matlab two values are strongly correlated. If one is increasing, the other is also increasing. So this is how we interpret two values. For example, installment. Let's take example of two values. So here let's take DTI and log this log annual. So they have it has a correlation, or let's, so the shades of yellow and green are strongly correlated. You can see from this diagram, and shades of blue are less correlated. For example, if we have uh, -0.54, yeah, -0.72, then that means it is strongly negatively correlated. If one value is increasing, the other value is decreasing. So this is how you interpret. So this was all about data science.